Good day, ladies and gentlemen. We're looking at moment of inertia for math M6. So let's go through this question. It says calculate the point of intersection of y equal to 3x and y equal to 3x squared. You see I'm underlining the important things in the question. Then sketch the graphs and show the strip. Then they've given a condition here parallel to the y-axis that you will use to calculate the volume if the area bounded by the graphs rotates about the y-axis. So once I read my question, those are the things that are important to me, which I can put them down. So I'm going now to the A part. It says we need the point of intersection of y equal to 3x. That's my equation number 1. Then y equal to 3x squared. Equation number 2. Then the other important information was saying strip is parallel to y-axis. These are things you must take down, not to forget. Then your axis of rotation is y-axis rotation. So in order to be on the safe side, this is what you have to capture. So we can then go on and calculate our point of intersection. So you can see that if you substitute equation 1 into equation 2, what does it tell us? It says 3x squared is equal to 3x. So when you are solving for x, you must look at the equation, check the degree. That's the highest power. It tells us that we must get 2 answers. So in order to achieve that, we must take everything on one side with 0 on the other side. So we get 3x squared minus 3x is equal to 0. So you must avoid dividing by x because you will lose one of the answers. Then from here you take out a common factor, which is 3x in bracket x minus 1. Then that will tell us that our x is equal to 0 or x is equal to 1. Since if we equate 3x to 0, you will get 0. If you equate x minus 1 to 0, you will get 1. And in order to arrive at your point of intersection, you must also substitute the x values into any equation up there. If I substitute x equal to 0, I get y equal to 0. And if I substitute x equal to 1, I get y equal to 3. So therefore, my point of intersection is 0, 0, and 1, 3. So those are my point of intersection. So once I've got point of intersection, they should guide me through the procedure of sketching the graph. So I will start by analyzing my point of intersection. You see they are all in the first quadrant, so that shows me that what I need is the first quadrant. So when I put my xy plane, that should be my target. I should make sure the first quadrant is visible, then I plot my point, that's the origin. I need the point 1, 3. So let's say this is 1 on the x. So this can be 1, 2, 3 on the y. So I need a point 1, 3. So that's my point of intersection. Those are my 2 points of intersection. So I must sketch the 2 graphs to pass through those points. So the first graph, we can see that's the standard equation of a straight line. So what I need to sketch a straight line is just 2 points, which I already have in the point of intersection. So I just link those 2 points with a straight line. I'm done with my straight line. Then if I go to the parabola, you see that's our parabola. From our knowledge of the parabola, that should be what we call the smiling face, which means we expect it to go like that since our a is equal to 3, being positive. So all it does is it moves like that through the point of intersection. So I'm putting my sketch, making sure it passes through the point of intersection. So there is my sketch. So it shows the region between the 2 graphs. So the next thing now is to put a strip in that region. You can see I have underlined my important statements. One of them is here, which says our strip must be parallel to the y-axis. So if this is our y-axis, a strip that is parallel to the y-axis must be a vertical strip. So I'm going for a vertical strip. So that is my strip parallel to the y-axis. So from there, you can shape the region between the 2 graphs. If we were not told to use a strip parallel to the y-axis, we can still use any other strip, because even horizontal strip can still fit in there, since it will always touch only the same two graphs, just like the vertical strip. So once you use a vertical strip, there is a condition on how to label your graphs so that you don't struggle with calculations. If I use a vertical strip, I must label my graphs using y. The first graph, which I call y1, passes above the strip. So according to this, my y1 is coming from the straight line, which is y equal to 3x. Then the graph passing below the strip is my second graph, which I will label it as y2, and that is 3x squared. Then if I extend my strip, you see it touches the x-axis, reminding me that under this equation, any calculation I'm doing, whether it is the calculation of the area, volume, area moment of inertia, my formulas must end with dx. So that is what it tells me. Then the second information is that you read your limit along the x-axis since the strip touches the x-axis. So guys, that's all about the A part. We can now switch over to the B part, which says we should calculate the volume. When I'm calculating my volume, the formula I will use for my volume depends on the rotation. You see, that's another piece of information I captured. If they say y-axis rotation, it tells you how your formula for volume starts. So your formula must start with Vy. Then how your formula ends, you look at your strip. If the strip in your diagram is touching the x-axis, it tells you how your formula for volume must end. So as an N6 student, that's all you need. Then you go to page 5 of your formula sheet. All the formulas for volumes are there. You search for the formula that starts with Vy and end with dx. So that formula will be 2 pi, the integral from a to b. In there, they will just put xy. So I have my x, but if I can look at my diagram, I will see that there is y1 and y2. So in the place of y, I will put y1 minus y2, even though you're still free to just copy xy dx. But remember that when you come in the place of y, don't forget that your strip is vertical and it's touching two graphs. The one above it comes first, followed by the one below your strip. So from there, you can now substitute our limit, the lower limit to the upper limit. We look at the x-axis, where we started shading to where we stopped shading. On the x-axis, you see when you end with dx, your formula must end with dx, telling you where you read your limit. So my limits are from 0 to 1. Then my x is there, my y1 is, I see it on the graph as 3x minus my y2, I see it also on the graph as 3x squared dx. Then I open my bracket now. This will be 2 pi, the integral from 0 to 1. If you multiply that, you will get 3x squared minus 3x cubed. Then you start your integration. If we integrate 3x squared, we're going to get x cubed minus 3 over 4 x to the power 4 from 0 to 1. Then we can now substitute our limit. We'll continue the side. So Vy is equal to again my 2 pi. The upper limit is a 1, so I get 1 minus 3 over 4. Since if I put 1 cubed, it's 1. 1 to the power 4 is 1. Then minus, I start the process again. I start again replacing x by 0, so that will be 0 minus 0. So from what I see, the lower limit gives me 0. The upper limit gives me 1 minus 3 over 4, that is 1 over 4. 1 over 4 times 2 pi, that gives me 2 pi over 4. Or better still, I can say my V is pi over 2 unit cube. So guys, that's how simple it is to calculate your volume. So the volume should never be negative. If you also like to leave it in terms of decimals, you just take pi divided by 2 in your calculator. You will see your answer. So that's how simple our volume is. So if we're fine, we can go to the C part. The C part says calculate the moment of inertia. So when I'm calculating the moment of inertia, the first thing I do is I check my rotation again. My rotation is the y-axis rotation. Then I go to page 6 of my formula sheet as an N6 student. I copy down the general formula. The general formula you see there for moment of inertia is written like this. The integral of r squared dm, where dm is an element of mass, because there you see that mass is defined as density times volume. That is on page 5 of your formula sheet. Then if you differentiate mass, it therefore tells you that density goes out. You get the integral from a to b r squared dv. So that is the general formula you see on page 6 of your formula sheet. So it's now your duty to develop this formula with the help of your graph. So this is what we'll do when we're developing this formula. The simple thing we'll do is dv is an element of volume. So what you will use in the place of dv is the exact formula we used when we were calculating volume. Then we'll need r, we'll go back to our graph. So let's start with dv. So for dv, I'm copying my formula for volume, which was the shell method. So that way you see 2 pi outside. If you combine it with this formula, density is outside, so I'll get 2 pi density, the integral from a to b. Then inside I'll leave some space for my r, so that I can then copy this part, which gives me x into y1 minus y2 dx. So I've incorporated my formula for volume into this formula. Then now we target the r. So to define r, the axis written here is very, very important, because your r by definition is the distance from the center of the strip in your diagram to the y-axis. So we'll go to our diagram. We start from the center of the strip, then we move in a straight line until we get to the y-axis. So that is it. If you look at the broken line I've used there, you see it's horizontal. Anything horizontal, we describe it using x, since the x-axis is horizontal. So that therefore tells us that our r is simply x. So I'm free to say that distance is called x, and therefore my r squared will be x squared. So there, I'm done with my r squared. Now I can start my substitution. So I get 2 pi density, the integral from a to b. My a to b here are the same a and b I used under volume. So that was from 0 to 1. Now you see that we have x cubed here. X squared times x is x cubed. Then my y1 minus y2 is the same y1 minus y2 I used under volume, or I simply read from my graph, which is 3x minus 3x squared dx. Then I open my bracket, I get 2 pi density, the integral from 0 to 1. If I open my bracket, I will now get 3x to the power 4 minus 3x to the power 5. If we can multiply the same way. Then we go to the integration part. So I get 2 pi density. If I integrate the first term, it will give me 3 over 5 x to the power 5 minus 3 over 6 x to the power 6 from 0 to 1. So that is it. Then we substitute our limit. So starting from the upper limit, so I get my 2 pi density. If I put my upper limit, which is 1, then these items x to the power 5 and x to the power 6 will be 1 each. So I'm simply getting 3 over 5 minus 3 over 6. Then 2 pi density, I start the process again. If I substitute 0, you see that the lower limit is 0. So I will not be bothered about the lower limit. What I will be concerned about is the upper limit. Simply taking 3 over 5 minus 3 over 2 minus 3 over 6 or 1 over 2, then I multiply by 2. So I'll quickly do that with my calculator. 3 over 5 minus 3 over 6, that gives me 1 over 10. Then if I multiply by 2 pi, it gives me pi over 5 density. So it means my moment of inertia is simply pi density over 5. If you are interested in the unit, it will be u to the power 5, since volume is u cubed, distance squared is u squared. So that is just to give you an idea of unit, even though we know those are not the exact unit of moment of inertia. So guys, that's how we get our moment of inertia. We can now look at the very last part, which says express your answer in C above in terms of the mass. So that should be a very simple exercise, because in our C above we've seen that our moment of inertia is pi density over 5. So if we want to express it in terms of the mass, this is what we simply do. We need some little knowledge from page 5 of our formula sheet that is telling us giving us the relationship between mass and density and volume. So from here, if you make density the subject, since you see density in your answer, you will be seeing that mass over volume is equal to density. So with this, it's informing us that for us to write in terms of the mass, we need to divide by the volume. So what I'll simply do is that I'll copy my answer for moment of inertia without the density part, because I'm replacing it by mass over volume. Then I divide by, why am I dividing? You see in this relationship, volume goes to the denominator. I divide by my answer for the volume, which was pi over 2. Then I multiply this result by m. So it's like I'm taking mass over volume. So if you do that division, it's like you're dividing 1 over 5 by 1 over 2, since density will cancel itself. We're simply ending up with 2 over 5m, or maybe better still 0.4 m. So guys, that's how easy it is to calculate moment of inertia and put your answer in terms of the mass. So thank you very much. I hope that will be very helpful.